We'll go one by one and then finish and then take a look.
Yes, yes. Actually, this, as you said, it is a heavy package.
I'm
Even
sorry?
Google Colab also prediction coming 1 minute, 2 minutes like that.
Yeah, yeah.
Sir, I have created the assignment links for submission, sir.
Okay. Thank you, Sakran.
Uh, do we need to install auto glow on every time when we run a new code for different model?
May not be needed, but if you're shutting down, like I mean, if you've done it Jupyter Collab, then every time you shut down, that will be taken out.
I'm creating a new file every time for each one of
No,
the.
then it's not needed. As long as you're running the same instance, it's not necessarily needed.
It is
You
not
can
working.
just import and then move on. But if you have shut down your instance for whatever reasons, then you will be required to do it again.
No, I'm not shutting down. I'm just opening the new file,
Yep.
but it's asking to install it. Without installation, not working the other codes.
Okay, something would have happened. I mean, if you're looking at the same file continuation, then you should not require that. But if it is asking, then go ahead and install it.
Okay.
Yeah. Test score is negative because it's error. So error is shown as negative. So that was the trick that I mean you have to keep in mind. So it is trying to maximize that. So the lowest error will be the highest negative value. So just do some Googling on this and you'll find out this works in a different way in AutoGluon. If you maximize the error and if it is positive, then that means your best model should have the lowest error. If you're doing a negative of that, your best model should have the lowest. Or I mean, sorry, the best model should have the highest negative value. So it works as the highest. So you'll see the highest negative values on the top. No? I mean, I remember that, but there might be some that I don't recall. But that's the concept. Okay. Do the feature importance and everything. And you can calculate your own error, like we have done earlier on. So you can at RMS. You found something?
Hello, RP sir. Vasu
Yeah.
here.
Yeah. So
Actually, I'm trying to fit the regression model, but it is considering it as a classification model. Not sure why. Can I share my screen?
okay. I think Manju figured out that one. So it was taking as a multinomial classification. So
Yeah,
you can actually
multi-class.
specify. You can specify. If you just do over here, let me just bring it up very quickly.
Okay.
Yeah. Problem underscore type is equal to this. But if you don't know what exactly is the
Can
command,
can you present your screen back?
yeah, I'll just bring it up very quickly. So then I'll show you. Hold on just a second.
Okay.
So if you don't specify clearly, then it is gonna infer that. But if you want that to be clearly specified, then I will just go to the right area and then share my screen. Let me actually share my screen while I'm actually trying to navigate to the right area so that you know what I'm doing. So all I've
Yeah.
done is I've just done the help on tabular production, and it gives me a very, very detailed write-up on how we should be looking at things and other things that you can optimize over here, right? So if I go to the very top over here, it says problem underscore type, right? So if you look at the hyperparameters that we pass on in this model are mentioned over here. So label, what is your problem type? So if you don't
Uh-huh.
specify something, then it will go by the like it will do the prediction for you. Like I mean, in terms of figuring out, you know, what type of options you're looking at. But if you go ahead and specify regression, for example, right? Then it will by default do a regression problem for you. So you just have to add that parameter, Basu.
Okay, problem type is equal to regression.
Regression problem. So you can just do a help on this, help on tabular prediction. It will give you this detailed summary. So these are the parameters that you have to pass on: label, problem type, evaluation metric, where do you want to save it, how much detail do you want to it, whether you want to do something in terms of the sample weight, all of those things, right? And there are many other parameters. So
Yeah.
like
Okay.
this, you can see, right? So over here, the main thing over here is problem type, which is a string. So you have to say whether it's a binary, multi-class classification or regression, right? So options are like this over here: binary, multi-class, or regression. Understood?
Okay. Okay. Yeah. Yeah. Yep. Yep. Trying it out now. Yes. Yeah. Thank you.
Quantile, I'll have to understand like what exactly it does. So basically, I assume that it's gonna do some sort of quantiling of the data, like I mean, putting them in different buckets. Huh? Right. So it will say like I mean, if you want to create 4 deciles, for example, or 5 deciles, right? So it's just gonna
Yeah.
put them in those sort of things. That's the quantile. We can experiment. If somebody wants to experiment, we can definitely experiment with that. Do that, and then hopefully that should work for you, Vasu.
Yes, sir. It is running. So I think at least I can see in the initial line it is not multi-class now.
Yeah,
In the initial
correct.
stage. Yeah. But the path variable there, I think if you have to save the model
Yes.
the model, then it will save that model to a particular path.
No, it will save the model. It will save the model in default. So, for example, if I go in my location, you can see it has, you know, automatically saved a model over here, right? So it will create all the things, whatever you're looking at over here. Like, I mean, remembering the model in terms of the predictor and all of those things, right? So it's gonna do that. But if you want to save it in a particular path, then you can do that. So, for example, instead of having a Google Colab path, I wanted to have in my local drive, I could have specified that. So all of those things are there.
Okay. Okay, sir. Thank you. But one thing I noticed here, like in the test data, so test data, what we had, I just ran the code which was mentioned in the web page, but in the classification problem, we took out the class labels, right? We removed the class label when we are predicting. But here, I think we didn't do that step. We are just running on the test data directly, which has even the age, right?
Yeah, you should make the prediction first, and then look into doing that, right? So, I mean, even if you don't remove it, it will remember that these are the actual values, these are the predicted values, and it will do it for you. But I mean, if you want to make it a very good case, then remove the actual values from your data, like we've done, and then make the prediction and do exactly the same thing that you've done earlier.
Okay. Yeah, it executed fine, so it ran through.
Okay, awesome.
So next is like we are waiting, or what do we do?
Yeah, I would like one of you to start like talking about some other things that you've done, right? And we will begin with the classification model, right? What all you see over here, interpretation. So who would like to walk us through their code and the interpretation of that? Because there's a lot of things that we've done, right? And then we will go through and look at the regression output as well, so that we at least know how to interpret that, right? Any volunteers who would like to go ahead and do that? Line by line, if you can walk us through. Bhavna, Manju, Tanmoy in the class first. Yeah,
Yeah,
or
I can do
online.
it.
Yeah, go ahead. Just
Okay,
share
so
your
let
screen
me
and walk
scroll
us
up.
through.
Yeah, okay. Let me scroll up to the top. Obviously, let me know once you can see my screen.
Yes, we can see it.
So basically, we just installed the required package here, first step.
You're beginning with the
And
classification, right?
classification, okay. What happened? This is strange. Okay, here it is. So basically here we are reading data from this location, setting the time limit, and yeah, setting accuracy as the metric, classification, and then here basically we are specifying what we have to predict using the AutoGluon tabular dot predict. Here we are setting, instantiating the initializing the class. So basically the label we are passing in, the class label. Evaluation metric is the metric, is accuracy, what we have defined here. And then we are basically fitting the model on the train data, and we are setting the time limit as well. And preset is equal to best quality, meaning identify the best model from all the iterations that it is running from this class predictor. So we are instantiating the data, instantiating the predictor class. And once the predictor class is instantiated, so we are running the leaderboard function on the test data.
Right.
Silent is true. What exactly does we didn't
Try to
discuss
make
that.
it false. Let's see what comes out. So it's gonna start giving you, like, all the different things. Yeah, plots and all the messages and all those things, right? Anytime
Okay.
you have doubt, just try it out. You'll see what really comes in.
Okay.
It will take some time, but you can continue going down.
Okay, the result. Yeah, so result also it's populated quickly, so it's good. So here it has tested different model like cat boost, like GBM, weighted ensemble, like extreme, and it's also sorting the result based on the descending order. So as we see here. And then again the test data, just looking at it, and then what we are assigning, we are just taking the test data label directly to the actuals, and then we are dropping it off from the test data. And basically then we are predicting the class label on the test data using the predictor dot predict class, predict dot predictor function. And then we are looking at the result here. Next step, what it is doing, evaluation. So basically the performance of the model using evaluate underscore prediction. So we are setting the actual values, what we have sorted out from the pie, and also what it is predicted on the test data set. And then auxiliary matrix true. So I need to change it and test it again. This what exactly if we set it to false. So based on that,
It will only
we
give
have
you the accuracy, so it won't give you any other metrics. Auxiliary metrics meaning, I mean, besides the accuracy, what really came out, like the MCC, F1, precision, recall, all of those things. Those are
okay.
like, the additional metrics it's giving you. If you're not interested,
Okay.
just change it to false.
Yeah, no, it's good to have all the
Yeah.
all the metrics. Yep. Yep. So here we see the recall is little low. So maybe we can see why it is, and we can try to improve upon in the next iteration. But yeah, precision is little okay, and also accuracy is quite okay. And then balanced accuracy. So you mentioned something, we can discuss that later, and MCC as well.
Yeah. I think balanced accuracies, they're looking at the weighted recall. I was just reading that in the sklearn library. That's where they've clarified that. But I am not really very sure about how to interpret this. So I'll just probably ignore that as of now, unless we do some more research on it.
Okay. Okay. Yep. And then the feature importance. So basically, this is giving the feature importance from high to low on the model that has been fitted using the highest accuracy score. That is, I think, yeah, the cat boost model, and which are all the features has the highest importance. So meaning which feature is covering the highest variance, or capturing the data from the input data sets. Like capital gain covers most from the input data set, followed by education, occupation, and age.
Right. Yeah. So let's take a pause over here. What are the p values signifying over here, people? What do you think?
P-value is
P-values.
significant.
Yeah.
So normally what we set is if p-value, so in the null hypothesis, is not significant, meaning it's not important. But if it is less than 0.05, it is significant. So if you look at this value, it is very low, which is significant, and it
But
has.
here the null hypothesis is not 95%. Here the null hypothesis is 99%. Because it's giving you a band of P99 low, P99 high. So with the 99% confidence, what the values are gonna be, right? So what you're looking for is anything which is less than 0.01 is significant. Anything more than 0.01 is not significant, right? So which variable is not significant over here?
I think here 0.01.
So this is 0.04, which is not significant, right? And the other way you can tell, Vasudev, is if you look at the range of this, and if the 0 is in between, then that means that coefficient could be 0 as well. So that means that it is not significant. So you can see the P99 low is negative 0.0004 something, right? And then I am crossing the 0 in between because I'm going from negative to positive. So 0 is in between. So that means it's not significant at the 99% confidence interval. So I'll say 6 doesn't play a role in the salary. So a lot of feminists will get all worked up. No, that's not true. Women are paid less and all of that. But it is the model is saying no, it's not necessarily true, right? But the reality may be different. I'm just saying just based on this data. What about race?
So these two you are talking about, officer?
Right. And these two are the like hot potato items, right? So I mean, people will again say, African Americans are paid less than white Caucasian and all of that. So the data proves otherwise. It says no, it's not significant, right? So that's where the statistical analysis really comes in, and then it becomes an evidence in the court as well. So, for example, XYZ tech company will say, I built a model, and none of these variables are coming out significant in my model, so I can conclude with 99% confidence that they are not significant. They don't play a role in the salary deciding, right? So all of those things. What about education? Is that significant or no?
Education is significant.
Yeah.
Education is significant based on what? It's 0.003, right? 0.003 is less than 0.01, so it is significant.
Yeah,
I'm looking at the bottom education. That is significant. because there is no zero crossing. It's positive. 99% is positive, right? So it's not going from negative to positive. So it is significant. Otherwise, you can look at the p-value as well, which is going to be 0.003. Right? So it is significant. So that's just, I wanted to spend some time talking about, what the p-values really mean. And when you conclude that these are the variables and significance, you should actually also highlight that, by the way, these are not important or these are important and so on and so forth. Right? So that's the significance behind that. Okay, so that covers the classification. Thank you, Vasudev. Regression, who would like to walk us through?
Yeah.
Yeah, by the way, before we go on, any other questions on the classification? I mean, you can always pop up the help and you can see, read more about that. But yeah, Tanmay.
Yeah. RP Parshram here. Can you just elaborate on the same P99 high value? Just
Sorry, just a second. Just a second. There is a question over here, Bhavna. Sorry, Tanmay is asking. Yeah, Tanmay, can you unmute yourself?
Okay. Yeah. If you go to the predict function, actually, so where it is
Go to the predict function of the
beat up.
Predict which function? Prediction?
Yeah, here. Evaluate
Okay.
prediction. Okay. So there are two sets of information, both accuracy and accuracy, the output. So is there any significance of those two informations? I think both are similar or same.
It's same. It's same. Repeated twice.
For some reason, it's printing twice. I think that's the only thing I can notice. Because they're exactly the same value.
Yeah.
Right. So something in the function, how it is actually working out. Did anyone figure out how to avoid this printing twice?
Semicolon, I think. Put a semicolon at the end. Sometimes it works. No.
No,
Okay.
I think by default it is coming twice.
Okay. Can you put a semicolon after that function call?
No, that is just to.
No. I mean to say just sometimes I have.
No, we have only
somehow
one line of code, so this should not problem.
Yeah, that's what the tricks. Okay.
Oh, okay. Good.
I read somewhere actually.
Yeah.
It was.
Why does it print twice?
I don't know, because of some old version or new version. So that kind of thing.
So there you go. Tanmay showed the value of a semicolon.
Okay, so it's good to know. Normally, if you're starting a new line of code, we use semicolon. Okay.
Any other question, folks, from anyone on the classification? I think.
I think Parshram had a question, Sir.
Parshram, you had a question. Yeah, go ahead.
Yeah, so RP, I have this confusion with this P99 high and P99 low. Can you just repeat how to calculate? Because you said that the P value is 0.02, which is lesser than 0.05. Should I consider 0.01 or 0.2?
No, it depends on what is the default. So if you go up a little bit, Vasudev, where you are calling this output, the code, there.
Okay.
Right. So here you're saying feature importance. And if you just do a quick question mark on this, it will say by default, we are taking 99% confidence interval, right?
Yeah.
And what does it mean by 99% confidence interval? It says your feature is importance and this is the relative importance, 0.04. But with 99%, the importance could be between 0.04 to 0.043, whatever that means. I mean, I'll have to dig up how the importance is really being calculated, right? But doesn't really makes any sense in terms of the absolute, because you're not going to write an equation, because these are all stacked ensemble models, right? So just giving you an order of magnitude in terms of why this is important or the other one is important. So still with the p-value, so we know that by default it takes the 99% confidence interval. That's why it's showing you the 99% interval there as well, right? Now, what does it really mean? So it means that 99% confidence, meaning I want to be 99% sure that this is significant. There's going to be only 1% probability that the variable I'm calling as a significant, but it's not significant in reality. So the probability of making a type 1 error is only 1%, right? In terms of the statistics,
Yeah.
but ignore all of that. What you're looking at is alpha is not 0.05, alpha is 0.99. Right? Or alpha is 0.01, not 0.99, alpha is 0.01. So if the p-value is less than alpha, then your variable will be significant. If your p-value is less than alpha, then you'll reject the null hypothesis and accept the alternative hypothesis that the variable is significant. Null hypothesis says the variable is not significant. Alternative says the variable is significant. So if P is less than alpha, then I will reject that and say variable is significant. So in this case, the first one, capital gain, that's like a very, very low number, e to the power -7. Everybody sees that, right?
Yeah.
E to the power -7, very, very low number. So it's almost zero.
Yes.
So it is significant. And now if you come down, Vasudev, to the very end. Sorry, hold on. Just, and then you look into these intervals as well, the P99 low, P99 high interval. And the idea is that this interval should not have zero. So, Parshuram, does the first interval have zero in it?
Like where?
No, like the P99 low, P99 high, will zero be part of this interval? No, right? Because we are saying the probability of, the coefficient to be 99%. Between the 99% interval is 0.043, or the value is 0.043 to 0.049. So there is no zero. I'm not crossing the zero if I want to get from the low to the high, right? You see that point?
Yeah, correct.
Yeah.
Correct.
In the second one, I'm not crossing the zero. Third one, not crossing the zero. Fourth one, not crossing the zero, right? Till we come to the stage of the last two
Race.
variables,
Yeah.
where I'm crossing the zero because I'm going from negative to positive, from positive to negative. So the moment you cross the zero, the variables become insignificant for that confidence interval. Or the other way you can look at is the p-value. So what is the p-value for race? Is 0.014. Is it less than 0.01? No. So I will not be able to reject the null hypothesis. Well, this variable is not significant. Race does not play a role in deciding the income. Is the English interpretation. Next one.
0.01, right?
0.014. Look at the number, no? Extended number.
Yeah, 0.014, correct.
Yeah, so that is not less than 0.01. I will not be able to reject the null hypothesis. So I will say this variable is not significant. Or the other ways, you can see that there is a zero in that interval that we're looking at, right?
But whenever we consider for a p-value, the standard one you considering lesser than 0.05 to reject null hypothesis.
No, if you want to go with the 0.05, then you can say. But in this case, the default is 0.01 or the 99% confidence. So I'm saying, given that I want to have that
0.01.
confidence level, I will conclude it's not significant. If you're looking at the alpha of 0.05, then it is significant.
So it's more than the 0.01. So it's
Correct. Yeah, you can change that confidence interval. So, for example, if you want to build a model, you can definitely change that, and then you can look at the feature importance, right? So then it will be significant.
Okay, now I understood. Can you please tell me where it was defined? Now again, please, I'm so sorry. I just missed it.
It is defined in that function. So if you just do the help on that function, the alpha is defined as 0.01 by default. A lot of parameters get passed on in any function by default. So it won't tell you that I'm using this, but you have to understand what it is, right? So just do the help on predictor dot, feature importance, and you'll find that. Somewhere over here, you will see the alpha being specified. Confidence, there you go, right? 99% default.
Default, yeah.
Yeah, so you can change it to 95% if you want.
Okay.
Okay, now, is that clear, everyone? All the classification related output? Okay, I take it as yes, everybody is clear. So now let's move on to regression. Who would like to walk us through the regression? Anyone in the class? Bhavna, you want to do it? Tanmoy? Okay. So Tanmoy and Bhavna will walk us through the regression output. Thank you, Vasudev, for walking us through the classification. So let's go on to the regression now. Yeah. Okay.
Thank you.
So we did the regression model on Boston housing price. And first we imported the data set. Then we set up the, then we fit the model.
Just I like this line so that.
Okay.
Why are you doing the X and Y separately? Not needed, no?
Yeah,
For
yeah.
this one, yeah, this is not
Yeah,
needed.
later we didn't use it.
Okay, okay.
So initially we did, but
Initially we did, but later we didn't do it. Okay, and we are setting up the metric accuracy and label as the house.
Metric should not be accuracy for a regression problem. RMSC. That may be the reason why you are getting something different.
RMSC.
Okay. If you specify something wrong, it may still go ahead and build a model for you, but then it's going to be
not
completely bogus, right? So for a regression problem, it has to be the RMSE, mean absolute error, things of that nature. How do you find out what are the metrics? Again, you'll do the help on the tabular data and it will tell you these are the metrics I can take, right? Okay. So now it will tell you like I'm optimizing for the negative of root mean square error. That's where I was coming in, that it will
Lower down the.
it will try to get as high negative of the root mean square error.
Yeah.
So that means to lower the error,
Yeah.
right? Okay, let's continue. It ran very quickly actually, in no time.
Because it is less data almost, I think.
Yeah.
This is only 700 data.
Yes,
Yeah.
exactly.
This
The baby data for it.
Yeah. I think those are not needed. Okay.
Not
This is
needed, no.
good. Now the predictor we are doing. So we have saved that file, saved the prediction values into that current location. Okay. And
So you're getting the other metrics as well, like the mean square error,
So
mean absolute error, R square. So
Yeah.
people who want the R square, you can see, you're getting a very good R square. Median absolute error is 0.89, right? So if you remember, we got around 4 in linear regression or decision tree. So it is basically able to lower it by, a lot more. Yeah.
So I had this linear regression previous one to compare.
Mhm.
So here we had around 3.34.
Well, here in this case,
no,
previously,
earlier we did
Earlier.
actually.
earlier, okay, got it.
Only when we ran linear regression.
Okay.
Yes, I'll run again.
So these are the different types of models that run internally and find out which is giving the best result, and random forest is giving the best result.
Yeah, let me just take a look.
Yeah, because of that test score is still higher to lower.
Okay. So it is saying that because it's optimizing for the negative of root mean square error, right?
Yeah.
my scores are
Huh?
Those scores are different.
Yours is getting the K leaders is the best one.
Minus 5.5.
Yeah. So that is also here is giving, but in a different. It is showing at the bottom.
For us, it is ascending order.
So I just want to make sure, can one of you see what is the code to get what is the best model over here? Like, find out which one it's calling as the best model, just to really make sure that we understand this negative score correctly over here. In my view, it is trying to say, I'm gonna, huh?
In the middle it will come. Mine it showed weighted ensemble L2.
Weighted ensemble L2.
The
You
third
are
one.
getting as this one,
Third one actually.
third one.
My scores are like minus 5.
Hold on, just go to the output, where you're fitting the model. I think it specifies that. Go up. Yeah, go up.
Up.
Wherever we are fitting the model, yeah.
yes.
Okay, hold on, over here. So auto glue on training complete, total line best model is weighted ensemble L2.
Best model.
Best model.
This model is weighted ensemble L2. Okay, come down now. Weighted ensemble L2 is the best model. Okay. So I think how it is working is, it is Square error.
Or valuation.
It is taking a negative of that. So, and these are like, I mean, within the noise level. So if you just run it on the, like, the training data, you will see that the weighted ensemble L2 will be actually on the top, because on the training data, it is saying that it is the best model, right?
Mm.
So that is what is happening.
The score value of weighted ensemble is good.
Yeah, that is just like k-fold split that is
Yeah.
applying. So I'm just looking at the test data score over here. Score test.
But it is not test data. It is what the problem.
It is not taking test data, yeah.
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 So specify your train data over here. Let's see.
Yeah, can I do one thing? Okay, can I just put that square bracket and put 500 to dot colon 500 colon. That's some. Yeah, it's running. Yeah.
Yeah, because I'm very surprised, like, how it is ranking it. So I just need to interpret that clearly. Okay, still not ranked order correctly. If it is, no, just Bhavna, do it on the leaderboard on the train data, whatever is the train data that you have created.
Generalize?
You have the train data name, no? Whatever is the name.
No, I think same Boston.df now we have trained.
You haven't done the split training test?
We have done
Really.
on train, right? Yes, let us see.
But train is not having that train X. No, it will not work
It won't work.
because the
You need
train
to have
is
your
Because
entire
bias.
data.
train is
So
not
train and
having
test split and then redo it. Yeah. Anyone else who has done this correctly? Manju, have you done it? You want to share, or anyone else? I think there are some pieces missing there, so that's
Yeah.
why,
That's why it is not getting. Yeah.
Yeah.
No. What you can
We
do,
need to
I
read
can-
documentation, but I think it is
I'm
just
not-
giving the negative sign, I think, but the
over there.
model at the
That
top,
fit
right,
model,
from
you
the
can
list, I
just
think
put,
that is the best model.
here.
yeah. So if
1
I
to
understand
500.
correctly, what it does is it tries to maximize things, right? So like in this case, if the error needs to be the lowest, that means the error with the highest negative value should be at the top. But I just want to confirm my understanding whether somebody has done it and then got that.
For me also, I gave train data on.
Doing it. Okay. Let's take a look at their own model over here, right? Let's just quickly go through their output.
Instead of Boston DF, square bracket, put 1 to 0 to 500.
I see one
I'm
note
looking
here.
at their own output now.
Colon,
Just give me a
5,
second.
yeah. And we
If
have
somebody
Can I
figures
share
out
my
this, they can
screen?
share.
Hello?
Yeah.
Okay, sir, can I share my screen? I just want to highlight something.
Sip.
Can you see my screen?
Yes.
Yeah. So you see here something root means squared error on the test data is this, and then there is a remark note. Scores are always higher.
Rest of the things.
Scores are always higher is the better.
Let's see.
Yeah.
And then it says this metric score can be multiplied by -1 to get the metric value.
That's what I thought. Yeah. That, I mean, it will always give you the highest value on the top, right? Because it's saying error should be as low as
No.
possible. But
Correct.
it's
But if you
multiplying that to
multiply
get to
by
the lowest
-1.
error, because higher the negative error, that means lowest the error that you're looking at, right? In terms of decimal. So that's correct. I mean,
Yeah.
but still it's rank ordering in a way that, okay, so maybe
we are minimizing the error, right? RMSE. So if you multiply this -1, so this has the lowest score. So RMSE has lowest error here. So
no, but go
RMSE we
up to
should.
the output that it is saying maximizing something. Yeah. Where you were reading that, I need to multiply that with -1. Scores are always higher is better. Okay, higher is better. This metric score can be multiplied by -1 to get to the metric value. See, that's what I'm saying. I mean, because that's what I remember interpreting that. So it says always higher is better. Maybe higher in the sense that after I take a negative, then which is the highest value? because then -9 is higher than -13. Okay, so that may be the thing. Like, I mean, it's looking at the negative value and higher is better. So the least negative value should be on the top. Do me a favor. Can you replace test data to the train data in this?
Here?
Test to
Okay.
train, yeah. Test to train, yeah. Because then it should exactly rank order. Because right now the rank order is breaking a little bit. Hmm? It doesn't change. No, that's fine. That's fine. I think I will tell you, I mean, how you should remember that. Yeah, it's slightly weird. I mean, just how the model fits actually the RMSE. I'll just tell you. Where is your output?
No, it's still running, so I just
Oh, okay,
called up
okay.
to see.
Basically, the way it's gonna
It
represent.
ran through.
Huh. So now, K nearest neighbor is your best model. Well, K nearest.
Yeah, K nearest is -3.
But then the output says the weighted ensemble is the best model, right? It's slightly confusing. No, but he's evaluating on the train data actually. That's why I actually wanted to confirm that you evaluate on the train data. Huh. You want to share? Both are same. Okay, go back and replace that with your test data.
The test data is here.
Test data is here. So weighted ensemble, this,
Yeah, basically it should give the same model. It's just changing the
right.
model.
No, I think this is fine. This is fine. So when you're doing on the test data, and I think it gave you the output that the weighted ensemble is the best model, right?
Yeah, test data,
Huh.
it gave weighted
So that's
ensemble.
fine. So let's remove the train data. I think I don't want to confuse you. Remove the train data. And then let's interpret that one only. Remove
Okay.
this one. Yeah. Now go up there, right? It will continue to work in the same way that the highest value will be on the top. Highest value for ROC is 0.98, for example, right? Versus 0.63, which will be lower than that, right? In this case, again, it's rank ordering in a way that highest value will be on the top. Highest value, basically in this case, if you take a negative sign, -9 is bigger than the -13. So that's how it's basically rank order. So it is telling you the same thing that weighted ensemble L2 is the better model, but it has, because it has taken a negative value, you should not look at the absolute value. You should look at the with the negative sign. Highest value is -0.64. I think this is perfectly rank ordering. I don't see any deviation. -0.66, -0.9.78, 79, exactly rank ordering, right? So the highest value will again be on the top. So that's what you have to constantly remind yourself, that the best model will be the one which is on the top. Why? Because it is having the highest value. In this case, highest with the sign of negative there. So weighted ensemble L2 is the best model again in this case. I hope that clarifies the doubt.
Yep.
Correct. No, it is just saying, when you're looking at the model output, you have to remind yourself that the best model will have the highest value. Highest score, right? Now, highest score in with the case of RMSE will be a negative value, right? So it says highest value is -9.68 versus the lowest value, which is the -13.98. And that's how it is rank ordering. It is doing certain calculation internally to optimize the function. That's what I was trying to explain, but I don't think, I have exactly the mathematical part that they are doing internally in the algorithm. But you just go and look at the final output. And the final output will say that this is what we are looking at. So the optimization is working on this score test. Now, how are they defining the score test vis-a-vis the RMSE? Because this is not RMSE. When you compute the RMSE value comes out very different, right? So it's not necessarily just a negative of RMSE. They are doing certain other things to really just find a score that they are actually looking at, that we may have to spend more time understanding. RMSE value comes in when you're doing the evaluation. So if you show, like, wherever you've done the evaluation of the metrics, you will see there is an RMSE, mean absolute error, all the. Can you navigate there? Who's sharing the screen right now?
Yeah, sir, if you see here, evaluation is root mean squared error on test data, it says. I think
Yeah.
internally it is calculating from the train data. So it is the RMSE value. Evaluation, root mean squared error on test data.
Right, but it is not exactly RMSE. So when you've done the final evaluation, can you come down to that code? Like, I mean, somewhere you've done that
No,
evaluate.
final evaluation.
The evaluation part, that will tell you
No,
MAE, RMSE, like what Bhavna was showing earlier. Similar to a classification model.
Yeah, I need to do that.
Yeah, so if you do that, no, but that is for the classification. I'm saying for the regression.
Yeah.
So you have your true values, you have your predicted values, right? Pass on that and say auxiliary matrix is true.
So is it the same class? Because in the link,
No, you
this
need
step
to
was
have
not
your
performed.
Y value separated. So you should have the actual value of the house prices, predicted values of the house prices, and then you're gonna do that mean absolute error. So this is what the actual interpretation of the RMSE will be, not the internal learning of the model. You have that, right? I mean, you can share. So Tanu is gonna share the screen, so you can see how it's gonna look like while you're running it.
Okay.
Right, come down where you have done that. Or I mean, is it higher? Somewhere you have done, I mean, she was showing me earlier. There you go, right? So there you go. So the root mean square error, mean square error, mean absolute error. They're still showing negative. They're still showing negative, but I think somewhere you have to multiply that by -1. Just the way they are actually defining that, right? So because root mean square error cannot be negative. Similarly, the mean square error cannot be negative. So just the way it is actually showing, they're saying you have to multiply whatever I'm telling you with -1 to get to the actual error part that we're looking at, right? So the actual error in the model was root mean square error was 2.39. Actual mean absolute mean square error was 5.7, and mean absolute error was 1.49. Right? That's how you're going to actually interpret that, right? So mean absolute error, for example, will mean that on average, you'll be off from the actual house prices by 1.49, either in the positive direction or in the negative direction, right? So that's how you're going to interpret that. The R square for this model came out to be 93%. So 93% of what happens in your house prices can be explained by what we have in this, right? Huh? No. R square, anyways, I think is not necessarily a very credible metric, right? So median absolute error is basically 0.71, right? So that means 50% of the houses will have error in their house estimation of 0.71 or lower. So, very, very good estimate compared to what we had gotten earlier on. So that's where your ensemble and the stack models give you a better forecast. Now, if you come to the variable importance, Pearson is more in terms of the linear relationship. So if I assuming that, I mean, there is a linear relationship, some derivation of the R square value. Pearson and the Spearman correlation, right? I mean, they are both measuring the linear relationship between the. It doesn't even care about the multicollinearity. That's why it's actually giving you a better result, right? So all of these are the weighted ensemble models. So they don't really care about any of those assumptions. Like, I mean, if it's a multicollinearity, errors are not normal distributed. None of those things really valid for the stacked ensemble model. They learn all that behavior. Yeah. Now we will come and take a look at the variable importance. There you go, right? So this is the variable importance. So it says the room is the most important variable. Why? Because the p-value is very, very low, right? Lower strata is the second most important variable. Distance from the city center, whatever the RAD variable is, I think it's like some highway related thing, right? Age of the property. What is the tax that we have there? What is B? Does anyone remember? Anyway, so parents to teacher ratio is also there. So come down till the very end. Let's see if there's anything which is not significant. Okay, so pretty much everything is significant over here. You've taken what alpha of 0.90 or alpha of 0.05? 99%. Okay. With 99%, I'm surprised that the chas is coming out. The zero is not there in the interval. So I think there is something that went on there. So one thing tells me it's not significant. The other thing tells me it is significant. Sorry, I'm looking at the wrong one. No, it is significant. 0.001, no? 0.001 p-value. Yeah, so that is significant. I was looking at the standard deviation. So that's why all of them are significant. So everything is significant. Room is the most important. Lower strata population is the second most important. Distance from the city center is the third most important. Access to the highways will be the fourth, and so on and so forth, which is all very, very intuitive. All very, very intuitive, right? I mean, that, yeah, it makes sense. And yep, that basically covers the classification and regression. Any questions, comments? When we come back, we'll pick up another set of activity. But at least you have two models that you can submit with your interpretation. Any questions, thoughts, people from anyone? If something is not clear.
Sir, I have one question here. When we do a regression model for the Boston data set, should we give importance to multicollinearity?
If you're doing any of these things in the AutoML fashion, no, absolutely not. You don't care. Multicollinearity or heteroscedasticity assumption, none of those things really matter. They're all just for linear regression. For the AutoML or decision tree, random forest, none of those assumptions you need to check. So even if you fix it, I'm not sure whether you'll get anything better. So let's say you know, no, let me just clean up my data a little bit, right? I'm not sure whether you're going to get anything better because they're already comprehending that these two variables are interrelated. So I'm going to give more importance to this versus other and all that. All of that is comprehended internally. Other questions, folks? She got around 2.9 something. 2.88. Okay. Yeah. So I hope now you know, like, I mean, any regression classification problem you get in your work, you can dump it over here and then you have your output. At least you have a prediction which is going to be very, very close to the best prediction that you can get. You can participate in Kaggle, pick up a problem. There's a problem which is there. I'm going to talk about the sentiment analysis, right? So somebody has shared some data from Spotify that predict the sentiment, right? So you can put your entry there in Kaggle using this. We're going to come back and talk about the sentiment and all of those things, right? So why not? Yeah. 100%. You should do it. Yeah. Strongly encourage all of you to do it. I mean, of course, I mean, there are many, many more things to learn, and we really cannot cover each of the things in more details today. But you'll see that, I mean, you will be actually coming in the top. That is what, my 100% confidence is. Because I tried it myself. I'm telling you, right? I mean, some internal courses, they're saying build a random forest, optimize this and all that, and none of that I'm going to do. And yeah. And, I just grabbed this tabular prediction, built it, submitted that, and it came out very good. The only thing that you have to really ensure is that it may overfit sometime. So that's why, because it will overlearn that behavior, stark ensemble models and all of that. So keep out a sample just for the validation and then say prediction is good or not. And if you're comfortable with that prediction, then you're good to go. So like, I mean, you got your data, you're doing your train and test. I'm saying keep out another portion, 10% to just validate your model. Post all your It's 120 people. We're going to take a break and we'll be back by around 2:10 post lunch session. Yeah. Thank you, everyone. Take care.
Thank you.
Shall we file the